Okay, ladies and gentlemen, so today's chemistry class, we're still on the topic of counting atoms, and we're going to discuss a couple of concepts and basically see how to calculate the average atomic mass. So, before we do that, let's go over some of the concepts that were mentioned today in class, and then we can get started with that real quick. Okay, so the first thing that we are going to talk about for today in today's topic is um, that masses in atoms, or masses of atoms, excuse me, masses of atoms expressed in grams are very small. So we know that for a fact that masses of atoms, excuse me, expressed in grams are very small. And when scientists study, or when chemists study chemical calculations, they use a relative atomic mass. So when chemists study um, so when chemists study chemical calculation, it's more convenient to use relative atomic mass. To use relative atomic mass. Atoms are very, or masses of atoms are very small, and because they're so small, um, when scientists or chemists want to calculate something like molar mass or atomic mass, and molar mass we'll talk about a little bit later on, they use more convenient. Um, they find it more convenient to use relative atomic mass. Now, one very important thing is to understand that scientists use standards of measurement that are constant and are the same everywhere. And the standard used by scientists, and this is very important, is the standard used by scientists to compare units of atomic mass is the carbon 12 atom, which has been arbitrarily assigned of mass. exactly one unified atomic mass. And one unified atomic mass, or unified atomic mass, is the atomic mass of any other. A unified atomic mass, or 1U, is exactly 1/12 the mass of a carbon 12 atom. The mass of carbon 12 atom. The atomic mass of any, and this is also important to know, the atomic mass of any atom is determined by comparing it with the mass of carbon, by comparing it with the mass of carbon 12. So there's a lot of information here, but real quick, basically the most important thing to understand is that masses of atoms expressed in grams are very small, and when chemists study chemical calculation, it is more convenient to use relative atomic mass. Also, it's well worth noting that scientists use standards of any measurement that are constant and are the same everywhere. So they try to use a measurement that's constant and is the same and doesn't have a lot of variation. The standards used by scientists, the standard used by scientists to compare units of atom is the carbon 12 atom, which has been arbitrarily assigned a mass of one atomic unit. Now they use carbon 12 because it's the most abundant source of carbon here on Earth, and it's the most stable one as well. It says, and then it goes on to say that unified mass is exactly 1/12 the atomic mass of the carbon 12 atom, and the atomic mass of any atom is determined by comparing it with the mass of carbon 12. So basically, all masses of atoms are used by comparing it to carbon 12. Another thing is that isotopes of an element occur naturally, or can be created artificially. And although isotopes have different masses, although isotopes have different masses, they do not differ significantly in their chemical behavior. So their masses, um, let me fix this here, guys. I'm sorry. It's there. This isotopes of of elements occur naturally or can be artificially or created artificially. That's good to know. And also is that although isotopes have different masses, they do not differ significantly in their chemical behaviors. That means that their masses will be different, but their properties aren't necessarily going to be affected. And the reason is because remember that what differs or what establishes chemical properties is mainly the number of protons. So we are going to see isotopes more abundantly than we would. Now, that being said, the mass of an electron is 0.00. So the mass of an electron is 0.00548. Unified atomic mass. The mass of an the mass number of a proton is 1.007276. U mass of a neutron One second, ladies and gentlemen, confronting a little bit of technical difficulties here. I apologize for this. Give me 1 second. Okay, and we're back again. I apologize for the um the inconvenience. So as I was saying, we know that the mass of an electron is 0.005486 units of atomic unified atomic mass, and the proton is 1.007276 units of I realize I wrote 5 and it's 6 of unified atomic mass, and the neutron, which math I'll give you in a minute. I'm just realize that I wrote it wrong. 6, and the mass of the neutron is 1.008 685 units. Or unified atomic mass. And it's also good to understand that the mass number and the relative atomic mass of a given nuclide are quite close to each other. Are close to each other. Okay, so let's talk real quick about the average atomic mass and then let's see how we calculate it, all right? So basically, the average atomic mass of a naturally occurring element. So the average atomic mass, and then we'll see how we calculate that, is the weighted average of the atomic masses of the atomic masses of the naturally occurring isotopes. It's kind of like when you are averaging something out in math and you say, well, basically it's this plus this divided by this. So pretty much that's what the average atomic mass is. It's basically the weighted average of the atomic masses of the naturally occurring isotopes. So not the artificial ones, the naturally occurring one. And there's a little bit of a formula. And basically it's the percentage of the isotope multiplied by the mass, of course, in grams, or unified atomic mass, plus the percentage of the second isotope multiplied by the mass. And by mass, I mean the atomic or unified atomic mass. So basically, I'll write the U because it stands for unified. So let me do that here. So let me fix that. So right here, this is basically the mass. And U just stands for unified atomic mass. Okay, so U. You're going to see our units in U. Now we'll look at this real quick in your book. And that will be basically the end of the video. So let me go ahead and look for that picture real quick. Or for that page, I'm sorry. And basically, we have copper. We have copper 63 and copper 65. So let's do that real quick. Copper 63 is an isotope of copper, obviously, and consists of 69.15%. So that's the percentage, though, the presence of it. has a mass unit of 62.929, 601 unified atomic mass. And then we also have the copper 65 isotope, and it's present in 30.85%. .85%, and has an atomic mass or unified atomic mass of 64.927, 794 units of atomic mass. Okay, so one thing that I want you guys to observe real quick here is that if you notice the isotope, for example, is 63, but the unified atomic mass is 62.9 technically, so you round that up to 63. So you'll see the unified atomic mass is similar, or that the atomic mass, actually, excuse me, is similar to the unified atomic mass. Likewise with 65, the atomic mass of 65 of copper 65 is actually 64.927 unified atomic mass, but you round that up to 65. So that's going to happen a lot. Now, in order to work with this, it's really simple. All you're going to do is you're going to write the percentage. Now, whenever we're working with percentages, ladies and gentlemen, we have to have it as a decimal. So 69.15% is actually going to be 0.6915, and I'm going to multiply that by the atomic mass, or the unified atomic mass, which is 62.92929601. You're gonna add that to 0.3085, because again we work with decimal places when we're working with our percentages, times the atomic mass. And give me 1 second. Let's see if I can open this a little bit more. Okay, let's see if I can do that way. Which is 64.927, 794 U, or unified atomic mass. And basically, what you're going to do here is you're pretty much going to multiply 0.6915 times 62.929601, and you're going to add that result to the result of 0.385 times 64.9277994, and the answer would be 63.55 units. So again, what I did here, guys, real quick, just to kind of express that again, is I multiplied the 0.6915, which is the percentage I turned into a decimal, by the atomic mass of copper 63. and I get a result, and then I add that to the result of multiplying 0.3085 times 64.927, and that equals 63.55 units. So guys, hopefully this will help out. If you have any questions, you know where to find me. So stay safe, and we'll see each other in our next class. Bye.